Now in this video we're going to look at one of my favorite components here. So it's the LM334. It's in the TO92 package, like a transistor right there. But what it is, it's a 3-terminal, like a transistor, adjustable current source. So we can program how much current we want to go through the actually through that pin and through the resistor and then down that way. And that will hold true, that current, even if you vary the load. No matter how you vary the load, as long as you have enough voltage to power everything. And I think it takes about 1 volt to keep this working. But any case, and then the rest of the voltage needed for the rest of the circuit. But any case, we have the resistor here, and the formula is 0.064 volts divided by the resistance. So I already did the math, and 6.4 ohm. I think I might have 6.8 somewhere, but I can't find them. In any case, that'll give you 10 milliamps, which, by the way, is the maximum current for this. And so don't exceed 10 milliamps. It's probably better to just stay a little bit lower. In this video, we're going to use 10 ohms to get about 6.4 milliamps. I don't have a 64 ohm, I have a 68 ohm that I'm going to use, but I think it still gives us 1 milliamp for whatever reason. And 100 ohms would give us that 0.00064 amps, which is the same as 640 microamps. I think you can keep increasing the resistance down to 1 microamp. I think that is what it's rated for to be reliable down to, is 1 microamp. And so here is the LM334 on the breadboard. And so there's the flat edge. So the left, or top in this case, right there is V+. We got R in the middle, V- down at the bottom. We're going to start with the 68 ohm resistor right there. And that's going to give us 1 milliamp of current. So that's going from R, the middle pin, to V- down there. And thus current will go through there and then through the load. But it's going to hold the voltage across the resistor so that the current stays steady. The meter we're going to set to measure milliamps of current, and the red probe for this particular meter you don't have to move, but some meters you may have to move it. The power supply is set to 5 volts right there. That's normally what I start off with, and I usually keep the current to at least 20 milliamps unless I'll need more, but I'm going to drop it down to 10 to help protect this component, because you shouldn't put more than 10 milliamps of current through it. If that's all the power supply provides, then there's no way to put more through it than that. But in any case, we should get 1 milliamp of current, pretty spot on right there. And there you can see 1 milliamp of current. So now what we're going to do is put a couple of LEDs in series. So I could just do it step by step, 1 LED, and then do measurements and the other one, but I'm going to kind of speed it up. So we got a red one and a green one together. They drop pretty close to 5 volts. 2 for the red one, 3 for the green one. It goes down a little bit at lower currents, like we have now, 1 milliamp, but still, you're going to see here that with the 5 volts at the power supply, we don't have enough to get 1 milliamp current. If I bypass the green LED, we do, and if I bypass both of them, of course, we have enough. But in any case, you can see the load change. We had the same current, but that green one's a little too much, so all I have to do is add 1 more volt and we're good. I already know that. So now we'll zoom in, and so if we had more LEDs, we'd have to raise it even more. 2 more for a red one, 3 more for a green one, and whatnot. So you got to keep adding voltage as needed to provide a bigger load. But otherwise, as long as you got enough voltage, the current is set. So that is with the 68 ohm resistor. So now we're going to use about 1/6 of the resistance. This is a 10 ohm resistor, and actually closer to 1/7 of the resistance. So we're going to get somewhere about 6.5 times the current going through it, because there's less resistance, more current. And so we should get about 6.8, I think, milliamps of current, something like that. There we go, 6.6. Now you're also going to see we got more current going now. As the component warms up, the current goes up a little bit right there. So that's one thing to be aware of. It's not perfectly true even as the temperature changes, but it's still not bad. You know, it changes a little bit. We'll bypass the green LED, And so you'll see it go up slower, but you know, it still goes up as it warms up a little bit. And then we bypass both LEDs. We got the same amount of current for the most part. That's the main takeaway. It's a current source. It provides a certain amount of current. Now we're on the more negative side. We could do the same thing on the more positive side. Doesn't matter. You know, the resistor goes to the same 2 pins. The load can be up there. Doesn't matter. The current goes to the V plus pin and then through the resistor and then like through the load. The V minus pin just helps hold that voltage across the resistor. Doesn't matter which side the load is on. But in any case, that's it for this video. Always turn off the multimeter and get it off of current if possible. Current is the easiest way to blow the fuse within the meter, and then to measure current you have to replace the fuse. But not terrible, but not fun either. In any case, check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. I put a link down in the description. That would help out a ton. I'll see you in the next video.